All right, so if I rewrite, okay, which two binomials you want to expand first is up to you. If you want to use the arrows, the repetitive distributive property, you may, or foiling, right? Or if you want to use the box method, it's up to you. What do you guys want to do?
What are the options again? Sorry.
You know those arrows where you just...
Yeah, sure.
Because we're going to have... You don't do all three at the same time. You do two, and then you pick up the other one.
Yes.
So do you want to go like this one, this, or do you want to do a little box?
The first one.
The first? Okay. All right. Which two? It doesn't matter which two binomials. These two with numbers or this one? Remember, you're going to get a trinomial that then you're going to have to...
Because it will be the same thing.
True.
Probably the first option.
Okay, so let's FOIL these two out. Yes?
Yes.
Okay, so... Pay attention.
Is it fine if we choose either, or?
Yeah, it doesn't matter. You're just going to pick two binomials and repetitively multiply.
Okay.
Ladies, right. Because I don't want to hit record and then you guys are wanting to phone it already. No, we're moving on. Right. Okay, so x squared, right? And you guys can go faster than me because this is all review work. Right? So repetitively multiply. Remember, you have two binomials. 2 terms times 2 terms. 2 times 2 is 4. So you know you multiplied correctly, you distributed correctly when you have 1, 2, 3, 4 terms. Okay, now you need to combine like terms, right? So this trinomial is equivalent to these two bi's, yes? So what needs to come down? The binomial that you haven't yet distributed.
Oh, I forgot about that. Okay. And then you multiply.
Yes.
Across again.
And now you distribute, except instead of a 2 times 2, look, these are two binomials. So what's 2 times 2? 4. So there was 1, 2, 3, 4 terms. Now you have a bi times a tri. I'm going to end up with 6 terms that you're going to have to combine like terms. So that's also your check that you didn't leave anything out.
Would it be x to cube?
Yes.
Okay.
So go.
Yeah.
I got it.
Remember, you are distributing, you're multiplying, so you add your exponents. So this x is an x1. This is an x2. So together, x cubed. And that's why it's a degree 3. So now what is x times 6x?
Sorry, what was that?
6x squared.
Yes. Here, let me move it up actually.
Was 8x.
Okay, and then again, x times 8 is, yes, 8x. So look, I took the 1 and I went times, 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 so I have 1, 2, 3 terms. So I didn't leave anything out.
What about the minus 1?
We're going to do that. So now you're going to take the second term in the binomial and you repetitively multiply. You just distribute. Now, do you want me to keep going in a line or do you want me to stack it? Line? Okay. So negative 1 times x squared is negative x squared. Negative 1 times 6x is negative 6x. Negative 1 times positive 8 is negative 8. And so look, 1, 2, 3, 4, 5, 6. I have 6 terms I distributed correctly. And now you have to combine like terms.
Yes.
And that's just how you go from from factor to standard form. It's just just repetitive multiplication. You just gotta distribute.
So how
Okay.
do we do that with a different exponent? Like how there's 3's and then there's 2's?
Hold on. Wait. Because this part, if I talk, I know I'm gonna mess this up, and I don't wanna mess it up. Okay, positive 8, negative 6, positive 2x. All right, come on, guys. For those of you that are doing it, double check my work.
Got it.
Really?
Yes,
Okay,
I got
good.
it.
So they're standard form, and we agree. Okay, what's your question?
Well, I was wondering. Oh, never mind. You already answered my question. I was wondering how we put all. I thought it was gonna be one thing, not like.
Oh, like one.
Yeah.
Oh no, it's small.
Okay.
So like, what would be the A, B, and C? Or like,
Oh, so A is 1, B is 5, C is 2, and then it's D. You add more letters. The alphabet just grows.
because I always thought it was just A, B.
Yeah.
That's sad.
And I'll put the video up today. Well, it's still recording actually. So now I'm gonna type this into Desmos, and you're gonna see it's the exact same graph that we have factored. Yeah. If I stop it, you guys know it blinks out. So let me just so I go to Desmos really quick.